Okay, hi guys. So today I will continue talk about chapter 6, which is the data description. So in this chapter, it has three subtopics, which is 6.1, Introduction to Data, 6.2, the measures of location, and 6.3, measure of dispersion. So without wasting time, so let's go. So this chapter is related to the statistic. So as the definition of statistics is not so important in the syllabus, so I just read it out only. Statistics is a science that deals with collecting, organizing, summarizing, presenting, and analyzing data in order to obtain useful information for decision making. It has a wide range of uses in the field of science, business, industry, economy, medicine, education, agriculture, and so on. Okay, the statistic is just like you have some information. You collect all the information, you collect all and you process the information like in the form of table or in the form of the graph like that, and you present it to the other people. So this is statistic. In this chapter, it is also have basic terms. So because I don't know these basic terms will come out in the UPS or not, so I just explain it. Usually, the population and sample will be asked together because they have some relationship between them. It will just us will like identify this condition is population or a sample. So population is the collection of all elements whose characteristics are being studied. Parameter is the summary measure of a population, such as the means or variance or standard deviation like that. It's called a parameter. Samples is a set of measurement that constitute part of all of the population. That is, a sample is a subset of a population. Okay, so we know that from this we know that the sample is a subset of the population. So the range of the sample is small. The things you need to count of a sample is also small, and a population is a large number and a large area you need to count. So in a population, you can be have some not just only one sample. You can also have two sample, three sample, four sample, and so on. And the last one variable is any measure, characteristic, or attribute that differs from for different subjects. So for example, if the weight of 30 subjects are measured, so the weight will be the variable. And another example, if the marks of 40 students, marks of 40 students of in the mathematics test are measured, so the marks will be the variable. And like if the age of each patients go to the clinic are measured, so the age will be the variable. The variable has two types, so quantitative and qualitative. Qualitative can be measured while qualitative cannot be measured. Quantitative it has interval data and ratio data, while qualitative has ordinal data and nominal data. So these four data not so important in the syllabus, so I just read it. So interval data, there's no true 0 point or fixed beginning, and the distance between each value of the interval scale are meaningful and equal. So for example, is the time, temperature, and age. While the ratio data has a defined 0 point, such as income, height, weight, annual sales, market share, and product rates. For the quantitative variable, the ordinal data has the rank, while the nominal data does not have rank. So the example of ordinal data, you see the income level. It can be low income, middle income, or high income. While the nominal data, you see the gender. The gender only can be boy or girl only. So that's not ranking. So the ethnicity have like Malay, Chinese, Indian. It also does not have any ranking. The eye color just state the color, and the blood type just state A, B, O, or AB. So they all does not have the ranking. So the most important is the population and sample will be us, and the quantitative and qualitative will be us. So we see the question. Identify which of the following are population or sample. So we see the A marks of all students in a mathematics class. All students, it does not have, does you need to measure all of it, so it is population. The second, the number of oil palm trees harvested per arc for 50 arcs in the land. This question you need to find for 50 arc only. It have just certain range, so it will be sample. The third one, the number of goat owned by 200 farmers. 200 farmers, you need to measure 200 farmers only, not to measure all, so it's just a sample. And the last one, the number of DVDs. So during the weekends, at all the DVD stores in Kuantan, you need to measure all. All. So measure all is the wide range, so it will be the population. So here's the answer. Next. Identify which of the following variables are quantitative or qualitative. Okay. So A, the number of house in a housing estate. This is just a number you can count because the number of houses you can count, right? So it is quantitative. B, the types of computers. You can just state the types, like the brand of computers, like Dell, Acer, Toshiba, like that, or MacBook. You cannot state any value, so it is qualitative. C, the hair color of teenagers. You just can say the hair color is black or brown or blonde like this. It cannot be counted also, so it is qualitative. The last one, the monthly electric bills. The bills you can be count, right, like 500 ringgit per month or 700 ringgit per month. It has a value, so it is quantitative. So here's the answer. Okay, so we go to the types of data. So the definition of data is the collection or observation. Like for example, like in the mathematics test, Ahmad score 85 marks while Mutu score 50 marks. So the 85 and 50 will be the data. So there are four types of data. The two main types of data is the quantitative data and qualitative data. So same as the quantitative and qualitative variable just now. So the quantitative data is one which the resulting observation can be measured because they possess a natural order or ranking such as age, weight, height, and mass. For the qualitative data is one of which numerical measurement is not possible. An observation is made when an individual is assigned to one observable mutually exclusive categories such as colors, types of cars. And just now I said the age have number, weight have number, height have number, mass have number. Like I'm 19 years old, the 19 is the number. Like weight, if like a boy is 60 kg, so 60 kg is also have a number, can be count also. Height maybe will be 178 cm, and the marks, like just now, Ahmad and Mutu, they all can be count. While the qualitative data, you see the colors. Colors you can state this is purple, this is blue, this is red, like this. You cannot be count. And the types of car you just like can say the brand only, like Proton, like Honda, like this, or Asia. Just can state the type, cannot be count. While the quantitative data has two types, discrete data and continuous data. The discrete data is a data that assume countable values, like the number of students in a class and the number of cars sold on any day in the car dealership. While continuous data is the data that assume any numerical value over a certain interval. So, example, the weight of students in the class and the time taken to complete an examination. Okay. What's the difference? This discrete data, like for example, the number of students in a class, like 40 students a class, 20 students a class, it's just a certain number. It does not have any range. The number of cars sold on any day. Like example, on today, 19 March, maybe got 3 cars sold. So the 3 is the discrete data because it does not have any range. For the continuous data, the weight of students in class, like can be 45 to 50 kg, 51 to 55 kg, 56 to like 56 to 60 kg, just like that. It has the range. It just does not have one number only. Like just now you see the number of students, one number only. The number of cars sold, one number only. Or the weight of students can be many numbers in a range like 56 to 50, 51 to 55, just like and so on. And the time taken to complete an examination. It like if like Xiaoming, he take 30 minutes to complete an examination. While she used 50 minutes to complete an examination. So it has the range also. So it's continuous. And the group data is grouped in interval are categorized into mutually exclusive intervals can be presented in frequency distribution table, histogram, polygon, and ogive. Like this. It has the interval. While the ungrouped data are listed in the sequence or in the form of a frequency table but without the use of intervals. As you can see, just a number 0, 1, 2, 3, 4. So the differences between these 4 discrete continuous group and group is the discrete discrete and the ungrouped. They too does not have the range, does not have the interval. Or the continuous and the group data have the interval like that. But this discrete and continuous, both of them does not have the use of frequency. They does not have the frequency, while this group and ungrouped, they have the use of this frequency. This got frequency. While these two does not have. So this is the difference between 4 of them. Okay, so go to question. Identify which of the following quantitative variables are discrete or continuous. Okay, so first, the number of handphones owned by families. You just can state 1, 2, 3, or 4, or so on. So it's discrete. The second, salaries of employees in the company. Because all of the employees won't have the same salary. So maybe if you are the supervisor, you have the highest salary, or maybe you just the newbies, the fresh graduate, so it have the low salaries, so it has the range. So it's continuous. The monthly water bills, because it also can be have the range, like someone need to pay 500 only, Someone may pay several hundred, so it's continuous also. The last number of children per family. It just can be stated like one, two, three, or four. So it is discrete. So here's the answer. Okay, the second. Identify which of the following data are ungrouped or group data. So got A and B. So you see, as you can see, A has the interval, while B just state the sum of the number with frequency because 5 occur 2 times, 3 occur 2 times, 1 occur 2 times like that. So the A is group data, while B is the ungrouped data. Here's the answer. So the stem and leaf diagram. So why you have this name? Because these diagrams look like the stem and the leaf. Can see? Like here is the stem and here is the leaf. So it's used to present and display frequency of a group of data without losing an individual information. Without losing information. So if you just record like that, all the data will be recorded. So it is the advantage of using the stem leaf diagram. Each value of a stem leaf is divided into two portions, which is the stem and the leaf. To construct a stem and leaf diagram, so each score will be split into two parts. Just now I said stem and the leaf. The first part usually the first digit or the first sum digit is called stem. The second part usually the last of the last sum digit. I think this you need to call digits. And make sure the data is in the ascending order. Here is the example. So for the symmetric data, you can see the distribution is uniform. Right skewed because all the data goes to the right, and left skewed because all the data goes to the left. The right and how to remember the right and the left. The right is their right side. This diagram's right side, not my right side. My right side will be go at here. This the side of this diagram. Here is the right and here is the left. Just for those who cannot remember right and cannot differentiate where is right and where is left. Okay, so go to the question. So first, construct a stem and leaf diagram and state the shape of the distribution of the following data. So got A and B. Okay. This I do on the spot, so you can see how to construct this stem and leaf diagram. First of all, you see this so messy. First, you need to organize it. First, you book. No. First, you need to count. Here have how many numbers? So here have 20 numbers. So okay, you know that the total number is 20. So you just write it in the ascending order. So go to 100 first, 103, and 119, and how many? Got 135, 136, And how many? 168. Okay, so the 100 maybe is finished, so we go to 200. So 200, 234, 245, 245, 256, 263. Okay, so I think the 200 is finished, so we go to the 300. So we have 301, 312, and 378. So I think the 3 is finished, so we go to the 4. So 4 have, okay, 402, 416, and 478. The 500 is 510 and 532. There's 2, and how many already? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I have 3 more number left. So that's why I say you need to count how many number first, so you can know how much you left. So I have 3 numbers more. So 600, 608, 653, and the last one is 700, 725. Okay, this is what I have. So the number is arranged in the ascending order, so now I can start to do my stem leaf diagram. So because for this case, I need to take these 2 digits to the stem here. This 1 digit, sorry, 1 digit. Because if as you see, if I did take 2 digits, 10 has one only, 11 has one only, this 13 has two, 16 have one only, 23 have one only. So all have one only, just the first 2 numbers. So my stem leaf diagram will be too long. So for this case, I need to take one digit, 1 digit to the stem and the last 2 digit to the leaf. So 1 to 7, right? 1, 2, 3, 4, 5, 6, 7. So for 1 have 0, 3, 1, 9, 3, 5, 3, 6, 6, 8. For the 2 is 3, 4, 4, 5, 5, 6, 6, 3. The 300 is 0, 1, 300 is 0, 1, 1, 2, 7, 8. The 400 has 0, 2, 16, 7, 8 also. 500 have 1, 0, 3, 2. 6 has 0, 8 and 53, while 7 has 2, 5. So I have finished my stem and leaf diagram. It's too long, so I just erase it. Okay. So lastly, you write the key. Because you just write like that, so the other people maybe will don't know what is this 103119 is what. Because it can be stated like 1.03 or 103 like that. So you need to mention the key. So for this case, the straight line 03 means 103. You take the minimum value as the key. So 103 is the minimum value, so I use it as a key. Okay, so we go to the B. It's decimal. So for this case, I need to let the first 2 digit first two digit to the stem and the last digit to the leaf. Okay, for that, let me count how many numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. Okay, you also have 20 also. So we just arrange it. So in ascending order, 3, 1.5 is the minimum value. Later we will use 3, 1.5 as the key. Have 3, 1 finished, so go to 3, 2.6, 3, 2.8. Go to 3, 3.3. Yeah, it takes a long time to do this. 3.7, 3.9. Here and here. So we go to the 3.3, 3.4.3 occurs 3 times. And 3.4.9, 3.4.9. Oh, just I see it. Maybe finish. Go to 3.5. 3.5.3, 3.5.4, 3.5.7 and 9. Go to 3.6. 3.6.0 here. 3.6.8. Oh no, here is 3.6.8. Sorry, 3.6.3 and 3.6.8. Now we go to 3.7. 3.7.2, 3.7.8. Last one is 3.8.1. It's the largest value. Okay, so we count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 values. So I completed the ascending order. So now we can straight. So 3.1 to 3.8. 3.1 has 5. 3.2 has 6, 8. 6, 8. 3.3 has 3.7.9. 3.7.9. 3.4 has 3.3.3.9. 3.3.3.9. 35. 3.4.7.9. 36. 0.3.8. 3.7 has 2.8 and 3.8 has 1. So the key, I take the minimum value, 3.1.5 means 31.5. So I have completed. So here's the answer. Okay, so here's the end of 6.1. So I will go to the 6.2, which is the measure of location. Okay. So for measure of location, we have ungrouped data and group data. So for ungrouped data, for both ungrouped data and grouped data, we will learn about mean, median, mode, and what quartile and percentile. This four we have learned it in secondary school. The percentile is new first. Okay. So for mean of state of data is the average number of all the data. As you can see, average of all the data, and it has written as this upper scroll x, and this is the formula of the mean, which is the sigma x. Sigma x is all of the data, sum of all data, and this number of all the data. So it is the conclusion is the average of data, of all the data. The median is the middle value of a set of data in ascending order. Then it chooses the median point. So for a set of data, when the number of data is odd number is 1, 1, 3, 5, 7 like that. So the median is the midst observation. When the number of data is even, so the median of the mean of the this half value and the half plus 1 value will be written as this. So let me just on the spot give some example. Okay, let me think about. Okay. Okay. So median of all the data. So example, I use this 17, 20, 21, 24, 28, 32, 36. So for this data, so the number is 7. There's 7 numbers. So the median will be the median observation, which 24. Well, I add on one of the number, I add on like 40, so n become 8. So the median will be this 24 plus 28. So it will be 36. So here is the 26. Here's the median. The mode is a set of data is the value that occurs most frequently. So for example, like if 17 occur 2 times, so the 17 will be the mode. So for just like that, for the previous case, like no repetition, so there's no mode in this data. So, but however, if like 17 occur 2 times and 20 occur 2 times, so both the 17 and 20 will be the mode. So if mean equal to median equal to mode, the distribution is symmetrical. But usually this seldom happen. If mode is smaller than median, median smaller than mean, so the distribution is skewed to the right. It's right side, not my right side. So if the mean is smaller than median and smaller than the mode, so the distribution is skewed to the left. Because all the data goes to the left. Okay, so we go to the quartiles. This is also simple. So the second quartile is the median. So this does not need say. So the first quarter is the 25% of the total number of data. The third quarter is the 75% of the total number of data. So we go to the example just now. No need, I have the example. So quarters are the value. So divide a set of data in arrange in ascending, usually ascending. Maybe got descending, but usually we see is ascending. Into four equal parts as shown below. So for this case, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it correct? I think it's wrong. So I just add on one number, simply one number. Okay, so the total number will be 11. So the median will be the most middle one is 29. And you see these two parts. The 29 divide this data into two parts. The first is this. You see the 17 is the most middle, so 17 will be the Q1. While the right hand side, this 38 is the middle one, so 38 is the third quarter. Well, the percentile is new for us, but it's not just hard. So the percentile is like the 10%, like for example, if for example I use this 10%, 10% for this data maybe cannot be used. I use this more easier. For example, what example? 17, 17, 20, 20, 21, 24, 28, 32, 36, and 40. So here got 10 number. Here got 10 number. So I want to see the 10 percentile. The 10 percentile. So the 10 percentile will be calculated as 10 per 100 and total 10 observation. This will be the first observation. So the first observation will be 17, which is at here. Here's what the percentile means. Another example, if I want to calculate the 70 percentile, so 70 percentile, it will be 7 observation. So 1, 2, 3, 4, 5, 6, 7. 7 here. The number will be 28. This is what the percentile means. Lastly is the interquarter range. Interquarter range is the differences between the third quarter and the first quarter. So just take note that the 25th percentile is first quarter, 50 percentile is median, and the 75th percentile is the third quarter. So question, consider a sample consisting of the following observation. So calculate, we need to do how many? 3 things. First, calculate the mean, median, and mode. Mean, median, mode. And B we see later. Cannot because B. A new sample is formed using all the above observation with the 3 values in part A. So the 3 values, which is the mean, median, and mode, will add on at here. For this new sample, so calculate the first quarter and third quarter and the interquarter range. Okay, so we go to the A first. Okay, so I arrange it into the ascending order. So the mean is add on all these 8 numbers. divided by 8, so I get 7. The median is the 8, so I get this half, also half plus this half. So I need to get this 4 and 5. This 2 is the middle one. And divide it, so I get 16. So for the mode, you see the 12 occurs 2 times, so most times, so mode will be 12. So from this part, I get 17, 16, and 12. So I add on 12, 16, and 17. So the n will be 11. You want me to calculate the first and third, so I find the median first. 1, 2, 3, 4, 5, 6. This is the most middle one. You split it as here, so here's the 5, here's the 5. So in left hand side, the 12 is the most middle one, so it's Q1, or you can use this formula, 11 plus 1 divided by 4, so you get the third observation. For the right hand side, you also can use this formula, 11 plus 1 equals to 12 times 3 per 4, so you'll get the 9th observation. So you get 22. And the equatorage is the differences between Q3 and Q1, so I will get 10. Is it simple? Okay, so I go to the group data. No, before the group data, I will go to one thing, the box and whisker plots. So a box and whisker plots so give a graphical description of a data using 5 measures, 5 parameters, name the median, first quarter, third quarter, smallest and largest values. So it shows the center is at here, the spread, and the skewness. Skewness is this line, so it can be presented horizontally. So the box extended from Q1 to Q3 and encloses the middle 50% of the data. The whiskers extend from the box to the lowest and highest value and illustrate the range of data. You see? Extend to here. So here are 3 types. So if the box, the length are almost the same, so it is symmetrical distribution. So it is positively skewed because all skewed to the right. So the left box will be shorter than the right box. And the another case, the negatively skewed, which is skewed to the left. So the left, uh, this this box will be longer than this box. For this, the media is nearer to the Q1, and this is nearer to the Q3. We just need. So to consider about plots, we have 4 steps. Wait, let me introduce one thing first, which is the outlier. Because something values are unusually small or large, the set of data may be an error of recording the data. So usually the unusually small or large data will be the outlier. As a guide, so points which are smaller than the lower fence or larger than the upper fence will call the outliers. So later we will count it. So to consider a box plot, so we have 4 steps. So step 1, we determine the first, second, and third quarter and interquarter range. Second, we find the upper fence and lower fence by using this formula. The lower fence is the first quarter minus 1.5 in the quarter range. For the upper fence is the third quarter plus 1.5 in the quarter range. Okay, step 3, determine the smallest and larger values within the two fence. Step 4, draw it and define and find is it have the outliers or not. Okay, so we go to the question. So draw a box and whisker plot to represent the data below. So as you can see, I have organized these 20 numbers in the ascending order. You can see this is the first step. First step, I arrange it and I find the Q1, Q2, Q3 and in the quarter range. Q1 is 3.4, Q2 is 4.1, Q3 is 4.85. Okay, the Q1 is the fifth and sixth value. The Q2, 7, 8, 9, 10, 11. And the Q3 is the here. Because the middle, you see how to, here had 10 numbers, here had 10 numbers. So the 5 and 6 have been plus sum up together and divide into 2. So this is how to find the Q1 and Q3. Next, find the interquarter range. Interquarter range is 4.85 minus 3.4, so I will get 1.45. The second step is I calculate the upper fence. Is upper fence Q3 plus 1.5 interquarter range, so I will get 7.025. The lower fence is the Q1 minus 1.5 interquarter range, so I get 1.225. The third, I define the smaller and largest value. The smaller value is 1.2, while the largest value is 5.7. Okay, from this data, you see 1.2 is less than 1.225, so 1.2 may be recorded wrongly because it out of the lower fence. So for the block spot, the whisker is drawn from the start from the second value because 2.5 is in this is larger than the lower fence, right? So the whisker is drawn from 2.5 to 7. So lastly, we plot it and define the outlier. Just now I said the outlier is 1.2. So here's the middle, 4.1. The median, Q2, Q1, Q3. This is the mean value and the max value. Or for here, you can write the new mean value is in order to not get confused, you can rewrite the new mean value is 2.5. So the lastly is the upper fence. This is the lower fence and upper fence. And the outlier is 1.2 because it fall out from the fence. So here's the answer. Okay, so we go to the group data. So for group data, just now I said the ungrouped data. The ungrouped data does not have uh, we go to the types of data here. Ungroup data, it does not have range, while the group data has range. So we go to the group data. So group data, you need to add on the frequency. While this ungroup data does not need. Here does not have frequency. Almost same as the ungroup data, just the group data you need to add on the frequency to the data x. So it total up will be sigma. So the total value is k and the initial value start from 1. So it can be rewrite as mean equals to sigma fx divided by f. For the mode is different. This is the lower boundary, LB lower boundary plus the class range multiplied by the difference. This is the difference between the mode class frequency and the previous mode class frequency. The D2 is the difference between the mode class frequency and the next class frequency. Just is it confused, right? So later we'll see it. For median is the lower boundary of the median class plus the class range multiply this. This is the number of data divided by 2 minus the cumulative frequency before median class divided by the frequency of median class. Later we'll see it. So the quartile is almost same as the median. So this is the lower boundary plus the class width multiplied by the k per 4, while k can be 1 or 3. This is sum of all data. It's a cumulative frequency of the previous class. This is the frequency of the class. Okay, percentiles. Also same as the median and the quartile. Just the difference is this k. The k can be 1 to 99. So just take note, this just now I said, so I not read it anymore. So we go to the question. The following table shows the cumulative frequency distribution table for weight of 50 students. So we know that n equals to 50. So here's the table we have. So first we need to determine the mean, median, mode. Second, we find the first, third quartile and in the quarter range. So C, find the value of n. This is need to find the percentile. Later we'll see. But before that, we will solve A and B first. So let's go. So A, mean. For me, I construct it the table, add on the midpoint and the frequency. Frequency, how to calculate is, here is 3, 12 minus 3, 9, 33 minus 12, 21, and so on. So for the mean, before it, I will calculate out all the data. So for the mean, the sigma fx, which is the 37 plus 3, 42, 37 times 3, 42 times 9, 47 times 31, 52 times 30, 57 times 4. All this sum up, I will get the 2,380. And n And just now I state n is 50, and is the frequency. So mean I can calculate 2380 divided by 50. So I will get 47.6 median. Median, for this data I need the lower boundary. I need to define the median class first. So n equals to 50, so I need to find the 25th observation. So it lies in this third class. So this is will be the median class. So the lower boundary will be 45. And fk minus 1 equals to this 12. Cumulative frequency, the previous class is 12. And the frequency of the class is 21. So n equals to 50, c equals to 5. So please take down that this, if the cumulative frequency is 0, you can straight away, no need to write it into the new table. And this is less than 35, less than 40, so the class boundary is 35 to 40, 40 to 45, 45 to 50. Is the class boundary, not the class interval. So just take note. So my lower boundary can just take from here. So I calculate the median. So LK equals to, so LK equals to 45. Let me write out. Let me rewrite. 45 plus is n is 50. 50 times 2, this 12, this is 21, the c is 5. So just calculate it and I will get 47.6 or so. So for the third is the mode. For the mode, I need to take the data. Need to define the mode class first. As you see, the 21 is the largest number, so 21 is also the mode class. So the lower boundary will be same as median, 45. Cumulative frequency of the previous class also same, is equal to 12. This no need, this no need. What I need is the class, yeah, the D1, D2. D1 I see 21 minus the previous class equals to 12. D2, 21 minus 13 equals to 8. Yeah, just like that only. Mode, so mode will equal to LB plus D1 per D1 plus D2 times C. So I just sub the formula inside. 45 plus 12, 12 plus 8, 5. So it will be 47.5. So here's the answer. For here, if you already master it, so you can just combine it, all you need at here. If you have mastered it, if you learn just learn this, if you just learn it, barely learn it, so you can just separate all the information you need. For like me, I have mastered it, so I just write all the info I need at here, and I just take what I need. Mean I need this, median I need this and that, this and that, this and that, and mode I just need this and that at here, and to find answer. So the second, find the first and third quarter. Okay, let me define the first and third quarter. So the first quarter is the 12 by 5, 12 by 5 observation, while the third quarter will be 37.5 observation. How I find is 50 divided by 4 and 50 times 3 by 4. So from this, the 12 by 5 is like at here also. So the 37.5 is like at here. Okay. So let me do it. So for me, I have find all this LK. This LK equals to, for this let me rewrite it, yeah. 45, because I can just take the 45 at here. Um, this is, wait, should be weird. Okay, so I find the LK is 45, N equals 50, big F is 12, small f is 21, and class equals to 5. Okay, so 45 plus 45 plus this 12 by 5 minus 12, 0.5 divided by 21 times 5. So I will get 45.11. This third quarter is 45. Also can just calculate it. So I will get 46.73. This is what I have. So I didn't notice that I have calculated, put this 44.5, so I changed it to 45, because you can straight away use 45 as this the boundary. Sorry, yeah, the notes. There's a mistake in the notes. It just can be taken as 48. The median, 25 minus 12, divided by 21 times 5 plus 45. 48.09. So this is what I have. And the midpoint will be 37.5, 0.5, 0.5, 0.5, 0.5. All will be add up by 5. So I need to calculate it. Yeah, I'm calculating. Two four zero five. Sure, so 2405. So 2405 divided by 50, I will get 48.1. So here's the mistake, so please take note. So for me, and you need to alert, this is because I also make the mistake, so you need to take alert. This is the class boundary, not the class interval. So in the quarter range is just the difference between the third quarter and the first quarter. So I just write it 46.73 minus 45.12. So I will get 1.61. The third one, the value of m if 90% of the data is greater than m. So 90% is at here, 90% is greater than m. M may be located at this point. So you need to find the percentile. So the 90-degree greater than m, so will be 10% is less than or equal to equal to m. So battery. So we calculate it. The 10 percentile will be the fifth observation. So this 10 percentile is like at the second class. At here, 10 is at here. The boundary is 40 with 45. So the lower class is 40. The bigger f is 3, small f is 9. The class is 5 and so 50. So LK plus k equals to 10. This will be 10, 10 minus 3, 3 divided by 9 times 5 plus 40. So I will get 41.11, Here's the answer. You can take a look. 5, 4, 3, 2, 1. Okay, so we go to 6.3. Okay, so for 6.3, we will learn about variance and standard deviation and the Pearson coefficient of skewness. So we go to the ungrouped data of the variance and standard deviation. So let me do some introduction. So two sets of data might have the same mean. They have the same mean, which is 25. But set A, most of set A you can see all is near to 25, while the set B is spread over further than the 25. So here is the graph of set A and set B. So the difference in the spread of data can be determined by the measure of dispersion, such as variance and standard deviation. So a bigger value of variance or standard deviation, the less consistent of the data. If the variance or standard deviation is large value, so it's less consistent, and the graph is more spread. So for ungrouped data, we have the population and the sample, but usually we use the sample. The population is like the formula with you in secondary school, but the sample, you need to times all the sum of the square data. This is the sum of the data square it. Divide by n. For sample, we need to minus 1. And the standard deviation, just square root it. So usually we use this green color. So effects of measure of dispersion, U is changed uniformly by two conditions. If you add or subtract, the variance and standard deviation will not change. That is V equals to U. If you multiply or divide it, the something will change, except the selain daripada variance dan standard deviation. As you can see, if I multiply it with K, so I get a new S equals to the original S times K. New S squared, so original S squared times K squared. You can see. Not only the variance and the standard deviation will change, the interquartile range and the range also will change by times the K. So the above effects are true for both group and ungrouped data. So now we go to the ungrouped data first. So question 1, find the variance and standard deviation for the data below. You have seven data. So in order to find the variance, for me, it's just simple you just add on 2 plus 7 plus 10 plus 9 plus 2 plus 5 plus 6 equals to 51. So for this x square is 2 square plus 7 square plus 10 square plus 9 square plus 2 square plus 5 square plus 16 square. So all of them you will get 519. So for the variance, you use the 519 minus 51 square divided by 7 and then divide by 6. So we'll get 24 by 57 and the standard deviation you just square root it, so you get 4.96. So here's the answer. For group data, is same as just now, so you just add on the F. Just add on the F. You can see the population also the same, add on the F, but usually the population is uncommon in our syllabus. So we go to the question. So the frequency distribution of the weight of 50 babies in KG Borneo Hospital is shown in the following table. So we need to calculate the variance and standard deviation and the percentile. So A. Okay, 50%. Before that, let me find the midpoint and the cumulative frequency come out. The class limit, so this is the class boundary because the data are repeated. So I find out the midpoint 2.25, 2.75, 3.25, 3.75, 4.25. So I will get this fx is 2 times this or this or this or this or this or. Sum up all. Sum up all, I will get 167.5. Well, the fx squared is like this. This value, it does not square. It just square this value. Square, 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 square. And sum up all. So please take note, yeah, the frequency does not square. Only the midpoint square only. So I will get 574.125. So n equals to 50. So I can calculate the variance. The variance by using the formula. So 574 by 125 minus this 167.5 square, 50, 49. So I will get 0.265. Well, the standard deviation is the square root it, so I get 0.515. The B. Determine a value of x such as 80% of data is more than x. 80% is more than x. So x may be at here and 80% is more than x. So the 80% more than x, so it means that the 20% here got 30% is smaller or equal to x. So I need to find the 20 percentile. So use 20% times the number 50 observations, so I will get the 10 observation. The 10, number 10 is lie at here, so it's lie at the second class with the class boundary 2.5 to 3.0. So the lower boundary is 2.5, big K is 2, small k is 10, and the class inverse 0.5. So I just add on the percentile, so I will get the 2.9. Here's the answer. Okay, last. It's new for us, which is the Pearson's coefficient of skewness. So the Pearson coefficient of skewness is given by, is written as big Sk equals to 3 times mean minus median, or uh, or mean minus mode divided by standard deviation. Median also can, mode also can. So this use of SK is determine the graph is skewed to left or skewed to right, like distribute to right or distribute to left. So it's SK is smaller than 0, so SK is negative, the value is negative. So the data distribution is skewed to the left. So maybe like that. If SK is bigger than 0, positive, then the data distribution is skewed to the right, skewed positive. If SK equals to 0, then the distribution is symmetrical. And please take note that if your data take is between negative 0.1 to 0.1, so the term slightly is used. So we'll see you later. So let me find it. Yeah, like this. If the SK is greater than 0, so it's positively skewed. So if SK equals to is smaller than 0, is negative, so it is negatively skewed. Here's the graph to show. Okay, let's go to a question. So the question, so given the following data, so first you need to find the mean, median, and standard deviation, and calculate the Pearson's coefficient of skewness and interpret your answer. So it's same. I find the midpoint and the frequency come out. And the mean, I use 4 times 5, plus 7 times 10 plus 10 plus 3. Like this, or sum up, I will get 536. The fx squared is 4 squared, 7 squared, 10 squared, 30 squared, 16 squared, and sum up all. I will get 6,458. So the n equals to 50. So I can calculate the mean is 10.72, and the median. Define the median class first. 25 is like at here, so the third class is the median class. So the big K is 50, small k is 13. So for the median, lower boundary is 8.5 at here. Sorry. 8.5, 8.5. Plus the formula of median, so I will get 10.81. The standard deviation, 6458 minus 536 squared divided by 50 divided by 49, so I will get 3.81 and square it. So the second, calculate the Pearson coefficient skewness. Now I have the mean, median, and the standard deviation. So I use the median to do. So SK, by using the formula mean minus median divided by standard deviation. So the mean will be 3. The SK will be 10.72 minus 10.81, 3.81. So I will get negative 0.0690. I get the number. So I need to interpret my answer. So you see, it lies between 0.1 to 0.1. It lies between 0.1, negative 0.1 to 0.1, and it is negative. So I need to use the term slightly. So the data is slightly skewed to the left or slightly negatively skewed. So here's the answer. So here is end of chapter 6, and I will continue to the chapter 7. So thank you for watching and bye.